Welcome to the video tutorials of mechanisms by mekanizmalar. There are two major steam turbine types. They are action and reaction turbines. The Curtis steam turbine we are going to discuss in here is an action type turbine. In action type turbines, the potential energy of the steam is converted to kinetic energy in the nozzle. The high velocity steam leaving the nozzle strikes the rotating blades of the first stage of the turbine. The name action turbine refers to this striking action of the steam on the blades. In this turbine, the rotation of the blades happen in the action direction. In the reaction turbines, the steam is ejected from the rotating blades like hot gases ejected from a rocket nozzle. During this process, the rotating blades react to this expelling of the steam by moving in the opposite direction. That is where the name reaction comes from. The Ljungström turbine we mentioned in our previous video is a reaction type turbine. The vast majority of the steam turbines are axial flow reaction turbines. The action type steam turbines are limited to low power generation applications, or the Curtis wheel type action turbines can be used as the first stages of the large axial flow reaction turbines. To show steam motion in axial turbine stages with 2D animation is a very difficult thing to do. The solution to this is to show a cross-section of the turbine in the axial direction without an animation. This cross-section is shown at the right side of the video. An animation of the steam passing through the blades is shown to the left. Also, a plot of the pressure and velocity changes of the steam is shown while steam is advancing in the axial direction. As you can see, there are many blade stages with a steam flow in between them in different colors. I used the color codes to show the purpose of the stage. The moving white circles are embedded into these colored flows. The purpose of the white circles is to show the direction of the flow and the magnitude of the flow velocity. The first stage shown with the red color is where the nozzles are located. This is indicated by NZ characters. Here the steam potential energy is converted to kinetic energy. As you can see in the plot, this stage corresponds to a substantial pressure drop, which in turn increases the velocity of the steam proportionally. The next stage shown with blue color is corresponding to the first action stage with moving blades. This stage is indicated by MB. The steam coming with a high speed from the nozzles hit the moving blades and push the moving blades forward. During this process, the direction of the steam is changed and kinetic energy of the steam is converted to mechanical energy. As a result, the velocity of steam is reduced in this stage, as can be seen in the plot. The blades in this stage are attached to the rotor of the turbine. The green flow in the next stage is corresponding to a stage where the steam velocity is changing direction. Here blades are stationary and attached to the turbine body. This is indicated by SB in the animation. The purpose of this stage is to direct the steam towards the next moving blades with the correct angle. If we ignore friction, the speed of the steam in this stage is not changing, as can be seen in the plot. The final stage is another moving blade section, which is connected to the same disc with the first moving stage blades. Here, there are only 2 moving blade stages, but it could be 2, 3, or 4. What is the importance of this? The point is that more moving stages mean less velocity reduction in a given stage. This will in turn reduce the rotation speed of the rotor where moving blades are attached. Thank you for taking the time to watch this video. If you enjoyed this video and found it to be useful, please subscribe to the channel and hit the like button. We appreciate your support.